speaking. I'm with the GSN team, and I'm here with our special guest, Mark Vestra, who is a product manager at Akvo FLOW, and he is in Amsterdam today. So hello, Mark.
Hello, Mike. Thanks for
Great.
having me.
Oh, we're really excited about having you here. For our audience, one thing that I find interesting is Mark's office is actually an old Dutch East Indies warehouse, and it's right on the water in Amsterdam. I visited with him in February. And what I like about it, since I'm in Toronto right now, his building is actually older than the country that I'm in. So just as we have a couple more people joining in, Mark, do you mind actually describing the space? It's beautiful.
Yeah, it's absolutely beautiful. It's right in the middle of Amsterdam. It has a very rich history, not all of it good, of course, because the East Indies Company, it sold coffee, but also slaves. So there's a certain historical responsibility we feel. It's a beautiful place. It has these huge wooden oak beams, and yeah, that tells you a lot about the function, namely that it was used as a storage room. And even what happened there is that the decision was made to sell Manhattan for, I think, 60 guilders at that time. So it's a building with a history.
Well, true, although I have heard about that particular sale, is that the native people who sold it weren't actually the ones who held title to it. But anyway, that will be for our next webinar. So let's jump right in. I'm going to just give a little bit of background on the GSN program for people who to whom it's new. So it's a really exciting multi-client study that we've been working on for a few years now, and we're really looking at what are the big world problems, the things that are toughest to solve, and how can we use a new model of collaboration to fix it. So we're looking at not just people and organizations, but networks of organizations. And I will mention some more in the follow-up for people who are new, how to find out about the research, because it's been sponsored by a lot of big organizations. I'll mention that as well, but the research is available for everybody. So if we get on to the next slide, if you look on the left, we talk about what do we mean by a GSN. So there's those 4 criteria that are there in blue. And basically, they're self-organized, self-governed groups, and they're made up of stakeholders from diverse areas. We have academics here, we have NGOs, we have governments themselves, we have some entrepreneurial groups, and we have combinations in between. And lots of experts have been working on this program, showing the potential of networking and the new models of networking. Now, also on the program, we've developed into 5 hubs. Today, we're also going to be talking about the job hubs, and Mark's going to be talking about how his program can influence jobs going further. And so you see the 5 that are there on your slides. And also, there's network cards. So for each one of these hundreds of organizations that we've looked at, there's a card for each. And for the homework portion for our audience, if there's an organization that you're involved with or one that you know of, which isn't up yet, we'd love to get in contact with them and add them, as long as they're meeting the criteria that we had on the previous slides. So let's jump right into it. We've done a case study on Akvo FLOW, which is available on the site. But maybe we'll send it over to you, Mark, for the people who haven't heard about it. Before we get into the specific application we're talking about today, can you give a little bit of background about the organization?
Yeah, absolutely. So Akvo is a non-profit organization. It was founded about 8 years ago. It stemmed from the water sector. What we do is we create software and hardware, open source, that is used in the field of international development. One of our tools is Akvo FLOW. Akvo FLOW is a data collection tool. It consists of a dashboard that allows you to create surveys, and it consists of an Android application that allows you to collect data. It's used at quite a large scale. At the moment, something like 45 countries. One of the first applications was in Liberia, where it was used to collect data on 10,000 water points. And that kind of work is still going on. In West Africa, at the moment, we're doing nationwide data collection efforts in some 7 countries. One of them is Nigeria, for example, where we are collecting data, at least we're helping the government to collect data on 400,000 water points.
Excellent.
These are exciting and very large-scale programs. We started in the water sector. In fact, Akvo means water in Esperanto, but now we are expanding to education, agriculture, and other sectors. So that's in brief.
Well, that's fascinating, and I think most people do know about Esperanto, but do you want to say a few words about that? It's really cool language for everybody.
Yeah, it's the funny thing about Esperanto, of course, was it's a constructed language and it has a rich ideological background, stemming from the idea that wouldn't it be great if everybody could talk to everybody around the world. So Esperanto was created as a very simple to learn language. It hasn't really taken off, unfortunately.
I know. Yeah. Well, I think for language fans like you and I, it's something that's very, very interesting. And of course, people who are used to English being the lingua franca are don't want to learn something else. But what I always tell them is, but if you know English, you know most about. You have a big head start anyway. But anyway, that's our third webinar. So let's go forward. We'll talk about the smartphone app that we're looking at today. So on the screen here is an example. So tell people what we're looking at here, please.
So basically, with Akvo FLOW, we have a data collection tool, and data collection is nice. You can already do a lot of stuff like answer questions. You can take photographs. You can take GPS locations, read barcodes, etc. But these are really exciting times in the sense that with a smartphone, you actually have a very powerful computer.
Right.
And so continuously we are looking at, let's say, expanding the reach and expanding the possibilities of what you can do with a computer, where the idea is that you use Akvo FLOW as, let's say, the data backend. So it can collect data and then ship it off to a nice central database. But to expand what you can, the type of data that you can collect. In the past year, one of the things that we've been working on is to develop a number of sensors, water sensors, so things that you can plug into your phone and that help you measure electrical conductivity, for example, or soil moisture, a number of things that you can quite easily connect with a physical sensor.
Right.
But there's also a lot of water quality parameters that you can't really measure with a sensor. Yeah, for example, if you look at nitrate, nitrite, or chlorine, iron, phosphate, etc., those are very important parameters for water quality, especially also in agriculture, for example. But you can't really have a good sensor to do that. However, there is another technology that does exist, and those are called strip tests. You might have known them maybe from your high school days when you measured pH. Little strips of paper that you dip into some fluid, and then you get some kind of a color change, and the color change tells you something about the parameter, like the concentration or the acidity level, pH, etc.
Good, and then so on the screen here we see on the smartphone the analysis is happening. So I'll go into the next slide, which is more of a close-up of here's what Mark's talking about. So you can see the strip that's on the black at the bottom. Maybe you can talk us through in more details about what's happening here in this card.
Yeah, so basically at the bottom you see one of these strips, and this happens to be a nitrite strip. It has two patches. Each patch is sensitive to a different substance. One is for nitrate, one is for nitrite. And the trick then is to read the colors. But reading colors, you could say, okay, just make a photograph and measure whatever the color is. But photographs, and any photographer will tell you this, that it's really hard to get colors right. Mm-hmm. So we said, okay, what we need to do is we will need to calibrate the camera. But simply calibrating a camera is also not enough. You need to calibrate each individual measurement. So what we see here is a card consisting of some 65 different patches of color. And we know these colors very well because we've used an industrial grade color measuring device. Yeah, it looks like a big mouse. It's also used in industry.
Mhm.
And what that tells you is exact color levels of these patches. So if we take a photo of this card together with the actual strip, then we can use these colored patches, of which we know that the exact colors. We can use that with some clever mathematics to do a calibration of the whole image, and then we can read the colors of the strip, and then we will know that these colors that we read are correct. And from that we can take the step towards the analysis of what these colors actually represent.
Okay, and you mentioned this is nitrate. So on the next slide here, this is a screenshot again from what we're looking for. So maybe describe this a little bit more. In the next slide, we actually see results. So this is happening in the field, and we have the person working on it that has their smartphone and the strip. And then what happens?
Yeah, exactly. So basically these strip tests, and you see an example here, they usually come in tubes. So the actual process of working with them is very simple. You take out a strip test, you get your water sample from a pump, for example. You dip in the strip. Sometimes you need to wait a few seconds, sometimes you need to wait a minute, but then the color develops and you need to measure it. Now, if you would do this without an app like this, of course it's also possible. You can just ask the person in the field, okay, please then compare the colors that have developed in the strip with the, and there's always, and you can just about on the right side of that tube, there's always a color scale that you can compare the colors to. You could just say, okay, do it by eye. That's fine, something will come out. But that process is quite error prone.
Right.
It's very easy to make mistakes. You can hold it upside down, for example. If there's two patches, it's very easy to confuse them. And about 8% of men is colorblind. Right? So to do it in that way at scale is quite hard. So basically here we guide the user through the process. So we show the tube so that the user can check if the tube that he or she has in hand is the same one. And then we have a small, let's say, indication of the process. So take out a strip, put it in the water, put it on the black area on the calibration card, and take a photo. So basically it's very, very simple. So basically the app takes care of the whole process. Maybe if we step back one slide, I forgot to mention. You see these black areas at the boundaries, the black squares. You might recognize those as being also part of QR codes. And actually, that's exactly what they are. So they're parts of QR codes that help the computer easily find where those symbols are. So basically, if you put a camera with our app above this, then the application will automatically locate these areas, and from there it can do the whole measurement automatically.
Very good. And we have an example of some results here from the nitrate. So what's happening on this slide? What does this slide tell us?
Yeah, so basically after the result is done, and during the measurement, a number of quality parameters are checked continuously, etc. So the app only takes a photo if it knows that, for example, there's no shadows, that the illumination quality is good enough, etc. But in the end, the app takes a photo, then it locates the strip. So basically what it has done here, it has used some computer vision image recognition to find where the strip is in the black area. It has cut out the strip, rotated it, and it knows where to find the patches. It has read the color of these patches and then interpreted the values according to the color scale that is part of the program. So that's what we see here.
And it tells us here parts per million specifically of how much nitrogen is in the water.
Yeah, exactly. Yeah, and then this result is of course stored as part of a flow survey, And that is also, let's say, a big part of the importance of this type of integration of a measurement app and a data backbone app such as Akvo FLOW, because you can have a result such as this, a water quality parameter, but it's combined maybe with a question of the GPS location, maybe the village name, maybe a photo of the actual well. So it has a big package of information with contextual information that forms the whole package that you send to the central database.
Right, and amongst the things I really like about this is how much more cost effective it is, because we're comparing to collecting samples of water and shipping them off somewhere to be analyzed. So we have the delay there. We don't have the contextual information that you just talked about. There could be contamination, but there certainly will be a cost and a time delay, versus in this case we can identify immediately impurities and act on it more quickly.
Yeah, absolutely. And of course, these tests are not as accurate as actual lab tests. And you should always see these as screening tests.
Yes.
But what is really powerful here is that you can, before, say you, in Mali, we're working on a program to test water quality on 2,000 hand pumps, which is just a pilot project. But already the scale is quite large. If you would want to test the quality of 2,000 hand pumps using, let's say, an old method of collecting samples and sending them off to the lab, you would have to pay something like $10 to $20 per sample. Right? So very quickly this becomes a very expensive exercise. And in this case, it might be very simple to collect, let's say, screening data on all pumps, because the enumerator is there anyway already to collect the data on location, etc. So it's just a matter of doing a quick strip test. And then maybe the results will be that in 5% of the cases, the values are very high. Okay, then for those cases, you make a sample and send it to the lab. Okay, so it's a very cost-effective way of sampling on a much larger scale and only sending those to the lab for which we have a good reason to believe that something is wrong.
True, and then I also like the point you made about the contextual data that gives us, longitudinal analysis. So we know this pump didn't have any trouble last year. Now it seems to have a contamination in a certain area. So you can do follow-up to say what has happened, what has changed with the equipment or the actual flow or use of the water upstream, that we can identify causes.
Yeah, and so that includes the GIS. So if you know the location of such tests, and we saw that in Mali, that it's very easy to make a map, obviously, after you have collected the data. And it was very interesting to see that you really could identify clusters of high results for nitrate. And so very quickly you can see, in this region, there's much higher or elevated levels of nitrate in the water. So both the longitudinal through time. Okay, last year there was not a problem, now there is, but also just the spread, the geographical spread of this data. It makes it much easier to analyze at scale.
Very good. Okay, well, we're going into the Q&A part of the presentation. So for audience, if you want to type questions into the chat menu on your panel, we can get to those. But I'll get you started off. Here's the picture of the gentleman working in the field here. And any sort of commentary more about this particular project, where this was, and what these guys are looking for?
Yeah, this was one of our first pilot projects to test out both the strip test measurement and also the EC sensors, so the electrical connectivity sensors. Those EC sensors you can actually see here in the little gray tubes that are lying in the middle on the black case, but also in the green cup on the right. So that's basically just a prototype of a simple electrical connectivity sensor. And you see 3 gentlemen here working with the strip tests. This was in Mali, part of a data collection effort of 2,000 water points. And it's basically a first pilot. So the system that we're developing here is not commercially available yet. We're still in the development phase. And this was yeah, this project taught us a lot here, especially about how to handle, let's say, noon sunlight levels in Mali, because we created this system in very, let's say, overcast European weather,
Right.
and then the and then the difference with 12 o'clock Mali sun is quite a bit. So this has taught us a lot, basically, about improving the user interface of this method. But yeah, so the app itself performed very well. And that was one of the most important things, so that basically the user doesn't need to do anything more than just hold the camera above the card, press start, and then the app handles, waiting for the right conditions, taking the photograph, doing the analysis, etc.
Very good. And I'd like to sort of get the Q&A started with, here's something that you and I spoke about earlier, and when we were in our pre-show, so our producer, we need to thank Jill Rundle, actually had a wonderful phrase. She's called it elegantly simple. So I'd like you to talk a little bit about how we have most of the computing power that exists on the smartphone, so that's not required to have additional things, and working on having the application being very, very simple. And I know it's, you said simple is powerful, but it's also hard to do. And given that even in the developing world, smartphones are ubiquitous, so people have these very powerful computers, and how do you set the philosophy to make something that is simple and powerful?
Yeah, so part of that philosophy, I would say, is simple is not easy. So making simple things takes a lot of thought and a lot of work. Um, Basically, I would say that we live in quite a special time in terms of developing new applications, new hardware, especially because let's say 5 or 10 years ago, if you would want to have an electrical connectivity sensor, or maybe something like what we showed here, a strip test reader, you would need to make the hardware, and the hardware would need to include all the logic, all the computing power. And this is what makes hardware expensive. You need to put in small mini computers, dedicated mini computers, that can take care of all the data analysis, etc. But now this is changing fundamentally, because now we have these fantastically powerful computers in our hands, and everybody has one, smartphones. So you can push as much of the complexity and the data analysis to the smartphone. And that means that the hardware part that remains becomes simpler and simpler and simpler, and therefore also cheaper and cheaper and cheaper. If you look, for example, in the case of the strip test that I just showed, it's a piece of PVC. That's it. That's the whole hardware.
Mm-hmm.
And of course, you need to think about it. It needs to be water resistant. It needs to be scratch proof. The colors need to be, etc., etc. But that's all. In the end, it's a piece of PVC. So you can make it for 2-3 euros. That's the whole hardware. All the mathematics, all the logic, all the computing power is in the software. But software is really easy to make, first of all. No, not easy to make, but easy to reproduce.
Right.
You make it once and you can make 1,000,000 copies, so that doesn't cost you anything. It's also easy to improve. If you have an update, okay, you send out an update. With hardware, if you have a small error, that's a big problem, because you have maybe, if you've just put out 10,000 of these cards in the wild and you find out that something is wrong, you need to distribute another 10,000 cards. So the logistics of hardware is completely different from the logistics of software. And this means that you can have very simple hardware, the complexity in the software, where you can regularly update it and improve it. And this is really powerful.
Yeah, absolutely. And I think from a GSN point of view, so again, that's networks working together, I think the data that you collect is now easily shareable to other organizations. So because you deal with water quality, that has impacts on so many other things. So obviously, health looks at geopolitical organizations. So are there any examples of the data that you've collected that you've shared with other networks?
Yeah, I would say the main So first of all, we always try to stimulate the partners we work with to make their data open by default. And to give you an example, in Liberia, when the data was collected in 2011 on the 10,000 water points, the government of Liberia made that data freely available for everybody, basically by just putting an Excel file on their website. So very simple, but very powerful. And what you saw is that many organizations actually used that data to do their own planning. For example, you had NGOs that worked with rainwater collection. They used that data to see in which parts of the country they could be most successful. You even had some youth organizations that looked at the data, found out which counties had the biggest problems, and started to pressure the government. And so the government was pressured with their own data. So that can be a really powerful dynamic. In terms of organizations where we also share data with, one important example is the Waterpoint Exchange network, which is basically a place where people can contribute specifically their Waterpoint data, where it is made available for download. Yeah, so we're involved in a number of let's say, open data initiatives around data sharing.
Very good. And I remember when the first time we studied you a couple of years ago, and in our interview you mentioned how you were pleasantly surprised that once you trained people to use the original Akvo FLOW technology, that they were, as we expected, they were clever and they were engineers and hackers, and they started using that for other purposes. And I think that one good example was they used it to report illegal fishing. And it just gives them an once we give them this technology, they're going to be clever and figure out other ways to do it. Have there been any other similarly pleasant surprises?
We've seen a few indeed, where people use, let's say, a flow instance that are used by organizations for other purposes. And we heard, for example, in Uganda, a case where people, the phones were rented out for data collection purposes. And this was really a great thing, very inspiring to see. And this is actually something also that we will try to stimulate more, because we think there is a great market for local organizations to collect data as a service. And we're moving to the Millennium Goals. We had the Millennium Goals. We're now moving to the Sustainable Development Goals. A lot of monitoring will need to be done to check if those are on track. And also governments are starting to use more and more to use data for their to manage their assets and their processes. So we see a big market for local companies, small local companies, that collect data as a service and perhaps offer additional services such as GIS analysis. So what we're really interested in is seeing if we can stimulate those small services locally, both with advice, maybe with access to something like Flow, but also with knowledge around other open source tools such as LibreOffice or Quantum GIS, Postgres maybe, Postgres for a database. So all kinds of open source tools that together form an ecosystem that companies can use to build up a service around data.
Very good, and that's very relevant to the Jobs Hub, which is sponsoring today's webinar. And before I actually ask this question, so a reminder and for the audience, if you have a question for Mark, just type it into the chat window. When I interviewed you in Amsterdam, you mentioned how this process changed how jobs are done, and even brought some good laboratories, scientific jobs into these communities rather than having everything shipped off. What other sort of impacts to jobs and local jobs has your initiatives helped with?
Yeah, so maybe two examples there. One again from the case in Mali. When we were doing the training with there were also two guys from a local laboratory. And first they said, this is really bad because this is going to take work away from us. If you can do the analysis in the field, people won't come to us anymore for analysis. But when we were there, and then they were with us in the field, and they saw how some of the tests gave high results, and that then a logical thing to do was to get a water sample and send it to the lab. They realized that it would actually increase the work for them.
Right.
Because it was now much more cost effective to send things to the lab, because you don't, well, there's a much better chance of having positive results. So that was an example where people really saw the benefit of, if you collect a lot of data, you need analysis, you need follow-up, there's a lot of work that is created around that. An example that was not so positive, of course, is when you look at how survey data is collected at the moment, which is usually on paper. And then, so if you step into an office where data collection happens, you will usually see tens of people behind computers with big stacks of paper, and the only thing they're doing is copying paper data in Excel files, right? And that kind of work, of course, will disappear, because if you use a smartphone to collect the data, you don't need to retype it in an office.
Right.
So work shifts. So on the one hand, yeah, jobs will, let's say the regular data collection jobs will become less. But also because it's much easier now to collect high value data, what we've seen is that more data is being collected because the value of the data is increasing.
Yeah, and I think if the jobs are created to do the analysis and then build policy based on the analysis and then have follow-up activities based on that analysis, should be higher level jobs and more sustainable jobs really than the data entry paper-based stuff that we're replacing.
Absolutely, but so yeah, and on that level, actually, I think there's a lot of scope, and I think let's say the skill set necessary to turn raw data into information, that's really a skill set that is lacking in many countries, and that is also really a place where well, the development efforts could help, simply to go to educate people on analyzing and understanding data. Also educating people on the possibility of using open source tools. Now, I recently visited Burkina Faso last week, and there I was at the National Institute for the Promotion of ICT Use. And there I also realized that, let's say the commercial organizations such as ArcGIS, Esri, or Microsoft, they have salespeople. And the salespeople go everywhere, including countries like Burkina Faso. But open source tools don't have salespeople. You need to know about them. Somebody needs to tell you about them. And otherwise, they go unnoticed. They don't have advocates. So one of the things, and I really see a lot of potential there for this type of development, is more attention for, let's say, more advocacy around open source software and what you can do with it, because it can really be used to as a fundament for small companies.
Very good. Now here's a question that came in from the audience. Was there any obstacles that you had to overcome from other organizations that thought that, hey, I'm being replaced here, or concerns about security or cultural differences, anything like that?
Well, let's see. So in the sense of data collection, I would say that this is a very old discipline. So people don't usually object to data collection because, it's been done by paper and now it's done by a mobile phone. There's not that big of a difference from the person that is being interviewed point of view. One thing that I would maybe want to touch on there is that it's really important that if you collect data, meaning that you take people's time that tell you information about themselves, if you do household data, for example, then you really have the obligation to give something back.
Yes.
You have the obligation to, and preferably something that helps the people that have contributed data to understand their situation. And I've seen a great example of that organization in India called Argyam, that went to 7,000 villages to do village-wide data collection. And then they took the trouble to create 7,000 individualized reports in full color, and they brought these to the villages. And this described the situation of that particular village. So they really took the time and effort to collect the data and then analyze it and bring it back to the people from which the data came. And I think that was a really great example of how it should be done. And of course, that's very often not yet done.
Right.
People go in, get the data, get out, and that's the last thing you'll ever hear of them. So
Well,
there's a lot of improvement possible there.
Well, I was going to say, and it gives another opportunity to work with other networks, because I think there will be certainly language translation opportunities we need to look at, and in some cases you'd be wanting to present information to people who weren't literate or were semi-literate, so there'd be maybe other networks that could help with both the translation and to turn this information into an infographic or a pictogram or something that makes it easier for all audiences to access the data.
Yeah, absolutely. I think especially in that sphere of intermediaries, so people that can take information and turn it into something that people can use, and that can be a mural, it can be a poster, it can be a radio program, it can be all kinds of formats that people usually don't associate with with data. I think especially in that space, journalists, media, those kinds of disciplines are, it's really important that they learn to work with data. And of course we've seen some beautiful examples like The Guardian, which have a data part. Also in the US, I think, not sure, New York Times, there's sometimes beautiful infographics. It's really a new discipline that is very important. And also in countries in Africa, Asia, where we work, we see that this is often lacking. And what it can easily lead to is a kind of digital divide, where you have the people with power and the people with the knowledge that they have the data, and that the people without power and without the knowledge don't have the data. And what it can lead to is a bigger divide between people. And this is really one of the social issues, I think, around data collection that we need to take very seriously.
Absolutely. Very good. Now, and again to the audience, if there's any additional questions, thank you for that one. Type them into the chat menu. I was curious, maybe you could share with the audience the initiative you were talking to Jill and I about using similar technology for soil quality.
Ah, yes, yeah, indeed. So basically, well, we're working on. Let's say, let me give two answers to that one.
Great.
First of all, we're also working on soil quality in terms of agricultural quality. If you look at agriculture, then one of the main things that you want to know is, do I need to apply fertilizer? And fertilizer is all about NPK, nitrogen, phosphates, and kalium, and potassium, exactly. Yeah. I miss the K always. So basically, and there again, it's hard to find sensors for that, but you can use strip tests to measure nitrogen, potassium. So we're looking at some ways to treat soil samples in a very simple way. You take a soil sample, you mix it with water, demineralized water, you shake, you select or you extract a water sample, and then you can do a very simple measurement of the soil quality. So that's one thing we're also at the moment looking into. We're not sure yet if it will work, but if it works, it would again be a very simple way to get an idea about the quality of the soil and if you need to apply fertilizer or not.
Right, and so now we're dealing with agriculture, food safety, and water safety. Very, very important. A question just came in that said, how might a new user with a new problem or challenge get started with the technology? An example here says, if I have a different element that is of concern than what is available in the test system. So I guess that
Yeah,
could just, that's an example of how you can just edit the algorithm.
yeah, exactly. Yeah, so basically what you would do is send me an email first of all.
Yeah.
But indeed, this system is very simple to expand. So especially the strip tests, of course. We've now talked about water quality strip tests, but there's many more. They're used in health, for example. Also in agriculture, for the cow urine, for example. There's strips that tell you 10 different parameters for a cow's health, just based on substances in the urine with a strip test. Very powerful. But also in industrial circumstances, for example, if you to look at various substances in wastewater, etc. So there's literally hundreds of strip tests that exist, and to use a new one, basically all you need to do, all that we need to do, is measure the parameters. So how large is the strip test? Where are the patches? How large are the patches? What is the color scale that goes together with this patch? And all of that we put in a configuration file for the software. And then basically you need to get the new version of that software, and then all of a sudden it can also read that type of strip test. Yeah, so it's really perfect. It's really software, completely software driven to support new types of strip tests. We're also looking at some other examples. For example, if you look at bacteria, E. coli bacteria, this is one of the hardest challenges in water quality. This is to measure the number of bacteria in water. One approach that we're taking there, and that's is to work with a physical sample holder in which you can introduce water and a growth medium, and it looks at the changes in turbidity and measures that. That's one option we are pursuing. And another option is that you might have heard of the, let's say, 3M Petri films. Very interesting product. It's created by 3M. It consists of a little square of cardboard with a circle in it. And basically it's a mini Petri dish. So what you can do is you can put a little bit of water in there. There's a little flap of paper that you put around it, put over it so it's closed. And then you have to incubate it for 24 hours at body temperature. And you see if there's bacteria, if there's E. coli bacteria present. And what we would like to do is, again, is to make an adapted version of this card that basically does the counting for you. So you can put on this strip test, or this Petri dish, Petri film sample. You take a photo, and the app does the counting of E. coli and storing of the data. So we're looking at a number of different ways that we can improve upon this and that we can use it. But basically, for any type of strip test that already exists, it's about half an hour of work to provide that kind of support.
Very
so
good.
If people are interested, they can simply contact us.
Well, another audience question relates to networking on that, and question is there a way to get in touch with other users that are investigating similar problems and find out what solutions they have developed? So maybe this is we find out that there is a certain element in our water. What did we do? What solutions did we undertake to deal with that?
Yeah, of course. In that case, Google is your main tool.
Yeah.
So fortunately, many of these solutions are created in academia, which means that there's a host of, that's really a wealth of literature on different ways of measuring different parameters, including PhD theses and all kinds of articles on different parameters. We actually have a lab in Bangalore where we are developing this E. coli testing, and that chamber also at the moment it already supports measuring fluoride, because fluoride you don't really have a good strip test for. So you need to have a fluid-based colorimetry solution. So that's what we are creating there. And so our lab in Bangalore, they really have some people that know much more than I do about different chemical substances that you can measure, different ways of measuring them, and the colorimetry and strip test approaches that you can take. Yeah,
Very good.
I was more doing the mathematics, let's say.
Right. Yeah. Well, I think that ties into more of what we're talking about with the GSN, and because you are creating the data, and that can be accessible for other people who maybe it is within the purview of their organization to deal with this sort of thing, but they have some real data to work with. So, as wrapping up, I think we can see here, the tools we've put together on this program can be helpful, and we encourage people to get involved with us as much as we can. We're going to be doing these webinars about once a month, and we've met many interesting people like Mark that we can introduce you to in greater detail. Also, if you're interested in having a colleague participate, we will post the recording of this on the website, and also the slides are available. And I think we can also add the case study that I wrote about Akvo FLOW a couple of years ago, and then we have a recent blog post that talks about this in details. Thanks again to our sponsors. We see the sponsors here. We're very pleased and honored to be supported by these organizations to help with this really interesting work. And of course, the biggest thank is to Mark for staying late, because this is near the end of his day in Amsterdam to talk with us. Really appreciate it. Any sort of final thoughts, Mark?
No, first of all, thanks for having me. It's been a great honor. Maybe one final thought is that I really like the idea of these of networks. And what we do, our approach is being as open as possible, being as discoverable as possible, and use open source tools. And this is incredibly important, because even if we don't have direct connections with other parties, everything we do, every letter of code is online, so people can learn from us as we learn from others. And this is a very powerful thing that we can do.
Excellent. Okay, well, and thank you again to Mark. Thank you for Joel Rundle, who is our producer, and we will be in touch with you for next month's webinar very shortly. Great. Thanks again, Mark, and thanks to all of the people who are listening.
Thank you.
All right.